Great, thank you very much. Mariam, thank you for this super realistic introduction. I thank AIA and all of those of you attending. It is very difficult to be able to spend time in the evening away from your families, and of course in this pandemic that we're in, there are all sorts of emotions that we're having to deal with. Just for a few words on this picture in front of you. This was done late November. As expatriates, as you know, we live very unusual lives, sit across different parts of the world. Work is one place, family another, and friends somewhere else. So this diagram was at the end of a fairly difficult period back in the UK when the pandemic was at its highest. And thankfully, around about the November time, the figures began to improve. There was hope and recovery. So there's an element of jubilation and color in this diagram, but still a lot of dark lines everywhere. But that's the life we live as expatriates. And to some extent, it's a responsibility we must carry because somebody has to stitch the world to keep it global. So this talk today is about the ideas get carried globally. AIA is a fantastic vehicle for that, as is the RIBA. And along with our colleagues in the aviation industry, the education sector, and the construction sector, these are the elements that help us to stitch the world together across different countries and nations, etc. So those are the few words about this diagram. And the talk was about the collaboration of all that you need to have in order to perform architecture. And without engineering, you cannot really do architecture because some of the more technical issues that need to be solved by specialists, and engineers are by nature specialists. So it's about collaboration. And when I chose the title, 40 years seemed quite reasonable, where some of the big changes were happening. And I felt that perhaps the articulation of structure, the ideas to do with sustainability and environmental engineering and fire engineering, these were impacting the way we were designing as architects. So I thought perhaps we go back about 40 years and pick up these threads and to see how they influence the architecture that we produced. And when this was happening in my own mind, trying to put together this talk, that I realized that my own career is about the same period, 40 years. So in some ways, a lot of the work I'm putting forward today is a timeline of my own projects. And the collaborations that I've had with some fantastic people along the line, and some of the issues that we have to solve, which I'm hoping that will be of interest to some of the younger people today. And I'm hoping there will be somebody in there who are my peer group. And so I won't actually, the talk won't be too irrelevant in that respect. The two buildings you're looking at in front of you, which I'll be talking a little bit more about, were some of the big ideas of our time. And in fact, they were the disruptors, if you like, for the profession. And this was happening at the time when the Apollo program was in full swing. We were glued to our screens watching those massive rockets go across space. And what that did to the architecture is extremely relevant. And these buildings that you're looking at are kind of a byproduct of that space age, that thinking that went away from the classical architecture and the traditional materials. And we're beginning to borrow ideas from the space industry, from the shipping industry, from the car industry, etc. And so I'd like to begin with this particular shot of Taj Mahal. The reason for this is that I'm, of course, born in Pakistan and spent most of my life in the UK, and then had the privilege of going back to these part of the world as a qualified architect and questioned whether, what relevance of these buildings and how they were actually constructed, and how come that these buildings are still there 350 years, from the time they were constructed. At one level, from a global perspective, when you look at a project like that, which has a tremendous world recognition, you realize that the nation that produced this has kind of arrived. They have the ability from the cultural point of view and from the point of view of supply chain to be able to get the artisan, the craftsman, to conceive, to design, actually produce buildings that can last a test of time. So as somebody who's born in Asia, spent most of my life in England, and now working in the Middle East, this seems like quite a good starting point for my own reference. So today, what I thought I'd do is pick up on 5 themes that I will kind of take through some of the projects that began in my early career to where I am right now. You will see from the diagrams that I showed earlier, there is an incredible amount of expression of the structure. Our structural engineering profession was kind of moving towards grasping what it needs to do, and in fact, turning into kind of sculpture. And you can see the full control of the engineering of structure. Together with that, the service engineering was also being developed, and it's almost becoming quite poetic in some of the early projects, and we'll be looking at that as well. And along the line, when you look at these projects, we needed to create new building types where huge movements of people would take place, airports and the like. And we needed to create methods of understanding what the risks were and solving those risks. Fire engineering was a fantastic example of that. And as we head towards the later 90s, we're beginning to realize the global heat problems in terms of the temperature rise and the like, and all those are issues that everybody's aware of. And sustainability became a big issue. Facade engineering then followed as a kind of response to solving all those issues. So these 5 strands, I'm going to try and take through the talk, through various projects that I worked on, and then talk about the relevance of the development at that time. So moving forward, this project is a good way of kind of sharing with all of the discipline leads that we now have to deal with, the structure, MEP, facade engineering, all of those issues are prevalent in this one project. And if you look at the back of it, you can see that it is truly a collaborative solution where the mechanical engineering, the structural engineering, and the architecture is supporting each other to come to a solution. A failure in any one of those would be a failure for the entire project. And I think this is a point where we know that we have to design as equals. We cannot go back, as it were, 20 years before this, where the architect would do a plan and the structure will then drop in his structure, and mechanical electrical engineer will then drop his engineering within that, and the builder will simply build it. This is a truly collaborative process, and the process of deciding, well, okay, well, let's allocate one facade for the entire engineering facade, which went to the back. The front of the facade had the movement of the circulation of the people. It also became a square which represented the movement. The picture to the top left is a picture that won the award for the photographic picture of the year. It was actually taken by an architect or an architectural photographer. It represents a very popular square in Paris, and you can see the formation of the circular pattern. The performers are performing, the public is watching the performers, and the building is watching the performance itself. It's a beautiful picture that won the prize. The middle one, obviously, it shows the relevance of our partners in engineering, in mechanical, electrical. All their work is color-coded. You can practically sit at the back of the building and do your degree in mechanical engineering. You know, it has all the ingredients for you to be able to do that. Bottom left is a craftsman trying to machine the gerberette, which is a cantilevered part of the building that carries the escalators horizontally and then the escalators at an angle. And this was designed by Peter Rice, and I think Ted Happel was also involved. So these were some of the most important engineers in the British history. The next slide is showing you all these fantastic people who were generating these projects, who were taking my generation of architects to a new level. You know, we were dreaming these projects, looking at the works of these people. You got the Jean Arthu's Sydney Opera House. The next to that is Peter Rice, who was the site engineer for the same project. He went on to do the engineering for the Pompidou Center. Ted Happel, who was also in the Pompidou Center, and went on to establish Bureau Happel, which and we've been working with them for several projects, and still continue to work with them here in Dubai. And that lovely picture with Richard and his team sitting on the structure of the Pompidou Center. To the right, Renzo Piano was his collaborator for the Pompidou Center. So these images are just collaged together, where the glass industry was moving to a new level. The structural engineering was moving to a new level. Bottom from the second to the left is an archway designed by Peter Rice for a project in Spain, which utilizes machined granite with stainless steel tubes to hold it together. And you know, it was a fun time for engineering in those sort of early 80s. At the time when Pompidou Center was coming to an end, Richard made his way back to England and won the competition for the Lloyd's of London. At that time, I was just finishing my degree, working in London, and watching Richard win this competition for the Lloyd's of London, which I will talk about in a moment. This next slide, across the pond, our American colleagues. They were doing fantastic work. Tall buildings, the Hancock Tower. On the left, you've got Bruce Graham with Fazlur Rahman, his engineer at SOM. And these guys were pretty much leading the scene in the SOM era of the 80s. And to the bottom left, you'll see the Hajj terminal, which was led by Fazlur Rahman in Jeddah. About 4 or 5 years ago, I spent about 3 years going literally every week to Jeddah, and I used to land in front of this building, and I used to be absolutely mesmerized by the engineering of this very simple structure. And in 2003, I did my Hajj in Saudi Arabia and actually landed underneath this beautiful structure. There's a bit of a story here. The tall towers, which were being engineered by SOM at the time, and Fazlur Rahman was quite instrumental in those. He had an idea to build the structure in the same way the trees has rings and gain its strength with more rings at the bottom and reduce rings as they go along. And how that comes across as a global idea is something that only an expatriate knows. And when you grow up in one place, you get your education in another, and you work somewhere else. You pick up these elements of knowledge, and that allows you to see how things come together. And I'll talk about the globalization aspect a little later, but so you've got the tall buildings happening in the US, which then are moving across the globe to the Middle East. And we'll see the growth of that in Dubai, where I'm spending a lot of my time at the moment. But this photograph also represents the time when there was major oil crisis, and there was an absolute lull in the tall building going forward in America, and SOM was actually stopped making any money, and they were looking for ways to find work in other ways. And one of the projects that came along was the Hajj terminal, which SOM were doing at the time. So moving on, I just want to say, pay my homage to this lady, Margaret Law. She was the lady who gave birth to fire engineering. She spent most of her life working for Arabs. And some of the engineers that we worked with when I was at Hopkins, used to bring her forward to solving some of the problems we were having. And I'll just kind of take you through some of those projects where we just needed her help, and she solved some of the most fundamental problems for us going forward. And some of the collaborators, some of the young engineers who worked for her are actually currently working in Dubai. There's a gentleman by the name of Dean McGrail, who's now with WSP, doing some great work with them. He also worked with us to solve some fire engineering problems, some of the projects I'll be talking about later. And another one of our students, or an early collaborator, I should say, was Martin Keedy. He worked on one of the projects we did with her at Glambourne Opera House. He went on to do something really magnificent, which I will talk about a little later. Lloyd's, fantastic project. Look at the plan, bottom left. An absolute simple rectangle, a beautiful diagram. It's a pure architectural solution to a very complicated site, City of London. All around that is these towers, almost crazy towers, lifts, staircases, that have been beautifully juxtaposed in the urban fabric of the City of London. And this is what Richard did when he came back after doing the Pompidou Center. And one of the first things he realized that he could not repeat the same act of doing steel structure. The regulations were different, and they simply won't work. So the top left diagram, you see the image of the concrete columns. They ultimately, the way they've been designed, they look as if been engineered as pieces of metal. But that was the level of care and the design development that took place. This is how Richard Rogers saw this building, and he was actually taking the concrete and the facade and all the elements that make up the mechanical engineering became almost like product design. And they kind of moved on a step from the Pompidou Center. The Pompidou Center was a steel structure which was cooled by pressurized water in case of fire to keep it cool. That wasn't going to work in the City of London, so the material changed from steel to concrete. And so this wonderful building, I ended up working on this project at the latter half of my career when I was working for Richard Rogers, and had the opportunity of looking at this sort of beautiful, beautiful work that had been done before I joined the team. And at the last leg of this particular project, Tado Ando was visiting England at the time, wanted to see Lords of London. I happened to take him around this building, spent a day with him, just showing around the project. And he couldn't speak a word of English. And to be honest, it didn't really make any difference. The building kind of spoke for itself. And he left an open invitation for him to sort of come and see him in Tokyo once. And he'll give me a day back, but I haven't actually managed to Tokyo yet, but inshallah, one day I will do that. Just wanted to show you this beautiful painting. It's by an artist called Ben Jonson. The reason I'm showing this is that this is another wonderful project by Richard Rogers is in Moss. It was for the Microchip Factory. A microchip in those days is a big thing, and factories had to be very, very special. This building has a structure. The roof doesn't touch the floor. The vibrations weren't allowed in order for be able to make the microchip. The building had to be vibration proof, and there was the issue that if the airplanes are flying over this building, that the vibration will impact the fabrication of the microchip. So this building is a very special engineering on its own right, but more importantly, this work by Ben Jonson, who glorified what the architecture was doing and the collaboration with the engineering. So this is a photorealistic painting of the architecture and the engineering that goes to make the architecture. And Ben Jonson was doing these wonderful paintings. On the left is Willis Weber. He is actually drawing the swimming pool and the plant that actually service that pool and the rest of the building. The picture on your right is the wonderful British Library extension by Norman Foster. And again, Ben Jonson is doing his magic in doing the painting of photorealistic architecture. Just going to move on a little bit to see what the Richard Rogers team went on to do after the Royals of London. They won this commission to do the Terminal 5 airport. And inside that, you can see the structure that holds the free span of the roofs that we're looking at. Is doing a number of things. It's just trying to hold up the shed itself, the roof. It's also trying to hold up the facade. It's beginning to color code the primary structure, the secondary elements that actually then pick up the facade, and is beginning to play around with what is important, what it needs to do in terms of the primary structure and those secondary elements. And it seems very clearly that the structure had to be prefabricated in a factory. They couldn't really be doing this on site, welding these huge members together. So the whole idea of designing these components then had to take a form where they can be made in small chunks in a factory and then brought together on site and just put together a piece of Lego. The foot of this detail here, extraordinary element where the engineering is actually moving in the realms of sculpture. And it is very difficult to kind of differentiate between pure engineering with WL/8 kind of calculations of trying to calculate the beams. This is just going a step beyond. And I think it's an absolutely magnificent piece of display of the control of what the structure needs to do well before it gets built. And have full confidence that when it comes together, it will be okay on the night. And this is an absolutely magnificent display of engineering. It's total control, absolute utter control. One other thing is worth pointing out, that you've got the shed holding yourself up, and then everything else that sits in it is quite separated. And the reason it's done that is because the British Airways realized that they couldn't afford to pay the architect who did the shed the same kind of fee to do the rest of the building. So the project got divided into two. You have the shed and the architect, and then everything else that went in it by another architect. And the two shall not meet. And you can clearly see that next time you travel in the building, if it wasn't already clear, you can see the A and a B, and it's an absolutely beautiful way of kind of separating the architecture. And to some extent, the same thing happened with Renzo Piano's project in Japan that he did for Kansai Airport. There is the external envelope, which is done by Renzo, and then everything else, the guts of it, was done by the local Japanese architects. Again, a magnificent piece of work, but you know, financial elements do play a role in all this. Just going to move on to another beautiful building. You know, great architects don't just do mega expensive building. This is a residential building in London, again by Richard Rogers. And it's a magnificent display of how you can create the mass and the volume to allow the idea of living to occur, but at the same time creating a watchmaking exercise, making these beautiful structures look, you know, as sculptural elements. This is a building was being designed when I joined Hopkins. It's a very small little building in Cheltenham's for a cutlery manufacturer. A cutlery manufacturer who had a huge amount of respect for architects, and he chose his architects, and he wanted a very highly manicured piece of design. So the columns that you see on the left-hand side are almost like toothpicks, but as they meet at the corner of the slab, there is an understanding that, you know, there's a relationship with the floor to be had, and there's a floor level change and a shadow gap detail to kind of move on. An element to the right is your lift shaft, and the structure is created by metal plates. Cheltenham is known for the industrial building, so this is a reflection of a modern industrial building. And the image on the right shows you these lead clad system that provides the insulation you require, and the steps. Again, product design there to show the lightness that you know, the architects brought to the project. Just a beautiful display of collaboration with the engineers and, of course, the architects. Just moving on, at the time the Lloyds was being done, Eva Jurikna was becoming quite prominent as an architect. She started her career with Richard Rogers and went on to develop her own career, and she became the queen of staircases. This is just an absolute piece of magic of a staircase, where the glass technology is brought to the forefront, and the structural engineers are getting involved in trying to understand, you know, what's happening to the glass, how the forces can be resisted, how the metals and the balustrades and all these little machined components that hold together these little bits of cage, if you like. It's just another refinement that's happening in the industry. And as a young architect, it's becoming a beautiful time to work in. You know, you'd want to get up in the morning and say to the client, "Oh, let's have another one of these staircases," you know. And we were doing this. It was absolutely fascinating. This was the project by, again, Norman Foster. And the reason I'm showing this, that I spent 22 years of my career with Michael Hopkins, Sir Michael Hopkins. And Michael was the director in charge of this project at the time when he was with Norman Foster. The first all-glass building on planet Earth, single glazed, green roof on the top, plenty of insulation there. And the actual surface area, although it's single glazed, is actually quite limited due to the large floor plate of the building. And what is important here is that one is glass, all glass building for the first time, but just look at behind the image of this picture on the left and picture on the right. The plant rooms are fully exposed. You will not hide the plant room. Mechanical engineering, everything else that has to happen needs to be displayed. It needs to be there. And the engineer who designed it has to be designing the full component of the whole lot. It's no longer acceptable that you hide these things. So this is just before I am actually becoming an architect who has to start engaging with the real world and doing real work. And this was the template of work just behind me, just before me. Again, Ben Jonson doing the painting of the building we're just looking at, the little sketch of the Norman Foster showing that this is how he sees the mobility of the people through the building, and the picture at the bottom actually telling you the sketch to the reality of what actually happened. It's an absolutely wonderful project. Another one of my favorites, again, Richard Rogers building, Sainsbury Centre, East Anglia University. Here, the structure, the engineering coming together. The reason I'm showing this is that the picture I'm going to show next, it has some bearing with this thing. The airport, Beijing. I visited this place about 10 years ago, literally a year after it's been finished. It's a project that needed to be done in 3 years. It's a project that needed to be done very, very quickly. And as an architect, if you have to sit down with a client and say, look, I need a building the size of this, and I've got only 3 years to do it, can we do it? And on a project like that, you really need to be starting to sketch, but also need to mobilize at the same time. You need to get the diggers on site in order to be able to make sure that this project is delivered. So some of the ideas that you're going to be seeing in these beautiful photographs are not new. These ideas have been well tried and tested from some of the buildings I just showed you before that. The ceilings, the structure of the behind the ceiling that carries all the mechanical, electrical elements, brings in the daylight. The columns in this particular case are point loads for a mirror frame structure to simply kind of sit in there to provide you the cover that you need. So as a designer, you can say, well, look, I can separate this project in 3 components. I can do the basement, I can do the element in between, and I can do the structure. I can get these 3 teams working side by side, and the contractors can be fed information literally on a daily basis, and they can be doing what they need to do, and the project can actually be delivered in 3 years. And at one level, if this project could not be conceived in a matter of a day, it would not have been delivered in 3 years. And I think some architects work like that. And it's been an absolute pleasure to be born at a time when this sort of thing was happening, and at some level, being part of it. This was a bridge, a viaduct in France. Again, a Norman Foster project, where something new was being done. And there is a degree of philosophy that went into how this needed to be done. There's a documentary on the YouTube you can watch. And what is mesmerizing for me is that for this project to occur, it needed to be solved in a particular way that if you wanted to see the beauty of what you were driving through, you need to deal with the nature, the elements that needed to be controlled. The side winds in this valley are extraordinary. They needed to be dealt with in order for you to have an experience to drive across this thing. And you just have to watch the documentary on this thing. But the experience of being able to drive and to have a windbreaker on your sides if you allowed the windbreakers to be designed for what they had to resist, you would see nothing, because you'd be well below the height of those windbreakers. But the way this got detailed and designed is that you create something that breaks the wind, but allows you to see through. So these macrolon pieces of glass, or the plastic, allows you the continuity of the structure, but also breaks the wind. The use of the extrusions gives you an element that you can actually see the beauty of. If you could stop and look at it close up, is as beautiful. But the idea as a windbreaker, to be able to see through as you drive to one of the most beautiful places in France, is just simply extraordinary. Here's an absolutely mesmerizing project by a colleague, an ex-colleague of mine from Hopkins. This is a pure understanding. It's a footbridge and a cycle bridge. And Robin Snell's was a colleague of mine. We worked together at Hopkins. He won this international competition. And the bottom left is just a simply mesmerizing image of the geometry of the helix of the cycle track, and the staircases in between that allows the pedestrian to walk through. When the competition was put together, it was quite obvious there was only one winner. And sometimes in life, these things happen. This magical solution just simply comes along, and it solves the problem so beautifully. And it's absolutely mesmerizing to see how a very simple idea just simply solves all the issues and actually looks majestic on the Thames. Another one of our cousins in the business, Grimshaws. This project is in west of England, Cornwall. An absolutely beautiful rendition of a structure. It's kind of a geodetic dome. The structure is lost in these hexagons that have these air-filled fabric structure that allows you to temper the temperature and everything. It's just one of those projects that, again, like the previous project by Robin, it just was brought together so beautifully. And if anybody wants to appreciate lightness of structure, just have to go and visit this project in Eden, in Cornwall. The scale is just absolutely mesmerizing. It's absolutely poetic to see the scale of the man trying to get access to the roof of this building. Okay, some real buildings. Back to my own career, back to Richard Rogers. At the time the Lloyd building was finishing, I joined the practice to help put together this project. This was Billingsgate Market, which happened to be in the City of London. They used to sell fish. The basement of this was essentially refrigerators, and the fish was kept there. And the city was booming, and the fish industry had to move out, and this building became empty. Citibank took over the building, employed Richard Rogers to create dealing floors, and the top left image shows you the finished dealing floors. You can see the wooden roofs on the top. Previously, they had glazing and ventilation. They had to be replaced with double glazing to contain the temperature and to reduce the solar gain. Richard had a wish that he didn't want any curtains or blinds or anything like that on the roof. And we employed a consultant from Austria to help us design a system which was some tooth acrylic elements that were designed in such a way that had mirrored images, which it kind of reflected the sun away, but allowed the daylight to come in. So they were designed with Siemens, and the young lighting engineer, who became quite a good friend of mine. In fact, we've been collaborating in UAE. So the artificial lighting, The daylighting was done by Barry Hannaford at the time. And as I said, not just the MEP, we're now also talking about the lighting designers. And so this was a project listed building. It allowed us to retain the timbers and keep the look of the structure to its original design, and deliver the building pretty much as grade 1 listed building, which remains quite a remarkable piece of architecture. Over to my first major project with Hopkins. It was a very young practice. They were delivering some fantastic projects, the Mount Stand at Lord's, the Schlumberger in Cambridge. Brilliant group of people, and they won this competition, international competition, against a lot of fantastic competition. And there was a realization that this young team had to do something really extraordinary to beat off the world competition and to be able to get a hands on this fantastic site. This is the old print works for the Financial Times. For those of you who know the news media, Financial Times has a pink paper. They're very highly reputable print media. They used to do the printing in this building you're looking at. The element in the middle was where the printings used to happen, and the two wings where all the admin was done. And at the time when this project came along, the scheme number 28 is the one that got built. And because of the nature of the site as being very important, some very high-end architects were invited by Obayashi, who were the owners at the time, to enter this competition. And the solution that the Hopkins came up at the time was just before I actually joined them. They already won the competition when I joined. It was this: the two wings that you can see left and right, very odd shapes. They reflect the medieval nature of the City of London at the time. And what the team did was carve out a relationship between the two that produced a very highly recognizable element of architecture in between. The architect has to recognize the importance of existing, but also has to stamp his own authority on the project that we understand and we will build on, and we'll make it as good as the original. The original was based on one of the palaces in Italy, and has these fantastic references by the architect who did that. And Hopkins came along, planted the element in between, allowed all of the elements the supporting elements, the staircases and all the lifts and all the servicing element to the right, and the core in the middle, which allowed the atrium space to be carved out. What actually allowed the project to be won was the fact that the project had already an existing basement, so the foundation was already there. To the top, because the building was quite close to St. Paul's, the heights were absolutely limited. There was nowhere to go, not even a millimeter. And the team realized that if they were going to win this project, they needed to provide an extra floor to the project to beat off the competition, to tell the client, so look, we'll get you the extra square meterage at no extra cost. And actually that's what happened. What you see on the diagram is the red elements are your primary structure, which then reduces in depth as it moves to the perimeter. That allows the green elements, which is your primary circulation of the services. So this solution actually is a pure collaboration of the engineering and the architects coming together, forming a solution where you got your race course of primary circulation of services that go to the risers, and the middle bit allows you to have a primary structure, and in return we were able to add an extra floor to the project. That actually made the project commercially viable for the owner to be able to commission Hopkins, which was a fantastic way of going forward. Back to Margaret Law, she was developing the fire engineering at the time. And at the point this project was won, it was very, very difficult to do an atrium space that wasn't hermetically sealed. With the fire engineering, we were able to work out the risks and convince the local authorities that we wanted to be able to have atrium spaces with openable doors, almost like an Italianate village kind of character. And being a headquarters building, it was able to, literally open your sliding doors, and you can have a different kind of character, a more homely kind, more domestic kind of character to the building. So this was only feasible by working with the fire engineering that was being developed at the time with Arabs. The image on the right is the image showing the proximity of the new glass facade to the old fabric of the City of London. And there was a rule at the time that you could only have so much glazing adjacent to an existing building. Again, with the help of the fire engineering, we were able to allow the glass facade to exist by providing systems within the building to mitigate any risks of the fire flying off to the buildings adjacent. So thank you, Margaret. At the same time, we kind of ring-fenced a budget with the client to develop some very, very special facade for the building. In this particular case, it was gunmetal. Gunmetal was kind of seen as requiring a bit more volume, if you like. Stainless steel would have been a lot more slimmer and sharper, but this one has a body to it. And the shape you see to the bay windows is a way of actually getting more net to gross for the landlord, but also the shape of these castings that you see actually represent the supply and return of the air. So its form follows function. And the gunmetal, again, was something that we agreed at the point of when won the competition, and it got then developed going forward. And those are the dampers as the facade lands on the load-bearing stonework. An image to the inside, glass block roof with the lift shafts opening up the volume of the elements within the atrium, bringing in the daylight. The fiber optic technology was coming to the fore at the time, so that was employed in this entrance canopy. Moving on to a next project, it doesn't seem very exciting, but believe me, projects like that are really good for the soul. At the time the Bracken House was coming to an end, I was asked to lead this project. It was the renovation of this gallery at the Victorian Albert Museum. This gallery is hugely important to the museum itself, but I think is hugely important to humanity in some respects. It has cartoons by Raphael, and Raphael is a very important artist, as we know. But these paintings they're unique, they're owned by the Queen, and they are very important places of, how should I put it, pilgrimage for the Christians. And this gallery wasn't just an exercise as a piece of architecture restoring the gallery to its original design, but it was also an exercise to create an ecclesiastical space for contemplation for the pilgrims. The original brief sitting with the curators was that these paintings are priceless. We want a gallery that's going to preserve them in case of any risk to the rest of the museum. Talking with them, it kind of transpired that this building had to be a black box. The image that you're looking at is being whitewashed to be able to be seen on the screen, but in reality, it only has only about 8 lux of light altogether. It's quite a dim space. And the issues were that originally the roof had lots of daylight. It needed to be.
Arif, apologies on interrupting. We are slightly running behind. If you can maybe wrap up in the next couple of minutes so we can give an opportunity also for the Q&A um, to proceed so that we can give a chance for people to also have their questions answered. But go ahead, we have a few more minutes.
If you can give me 10, I can deal with 10. Is that okay?
We might, if we can try within the next 5 minutes, that would be great, actually.
All right, I will do that.
Okay, thank you.
Okay, so this gallery had to be restored, and they wanted 16-hour fire protection. In comes Margaret Law. She works out that you only need an hour and a half maximum. So we were able to deal with the whole thing with very simple curtains, etc. So again, thank you, Margaret Law, for this beautiful solution to the problem. And I'm just going to skip this project where we were trying out prefabrication and natural ventilation strategies that went on to be used for our future projects. Here you can see some prefabrication happening at the Inland Revenue Building, which was a project led by my good friend Bill Taylor. This is the strategy for natural ventilation of the building. We were becoming concerned with how buildings were using energy, etc. And we're trying to design strategies that minimize the use of energy, a reduced amount of all the mechanical gear that goes on with putting together these buildings. Again, another beautiful buildings, a very different kind of fabric. This time it was an opera house where we're using natural materials for structural purposes. There you have your precast concrete with timber and utilizing a new novel way of producing air conditioning into this space without making a lot of noise, which is very important in an environment like that. Here we're now using brickwork because the building requires a lot of mass. And how the brickwork is integrated into the structure is an interest that, as Hopkins, we were pursuing at the time. And this is a project in the Far East. I went away there for a few years myself, and I was asked to do this building for a telecommunications company. Is a tower. Some of the ideas came from Lloyd's of London. But you can see the sunshade on the top was a gesture that I felt that it was a way of articulating this building in a very, very powerful way. So this is probably one of the biggest sunshades on planet Earth. It has a kind of 50% solidity about it, but essentially it cuts the 4-degree angle from of the sun. And these are some of the drawings at the times that were done. It was a very small team. It was the engineering was done by Atelier One. Our friends Scurvy Elvis, Neil Thomas, and Patrick Belly with Mark Garrison, who worked with us on this project. So it's a beautiful way of doing a project on your own, where you're doing your specifications, you're doing your drawings, and actually the construction management and delivering the whole project. So this is kind of a solo project done by myself and my 5 architects who came from the Philippines. Abdul Wahid al-Wakil was doing a building at the time in Brunei. I was his architect doing this building at night, doing this building at daytime. What a contrast, as you say. But he was a fantastic influence to work with. This building didn't need any audiovisual system. You could stand in there and recite and speak to have your sermons without any microphones. Moving forward, this is a project in Piccadilly, London, just a courtyard. But to do a courtyard in the way they did them in 200-300 years ago is an art that had to be learned. And a year of my life went in there to try and put together this courtyard. The fountains that you see were the position of the stars of the night Sir Joshua was born, the man behind the Royal Academy. This is a beautiful project. It's the Westminster Underground Station. It's a pure manifestation, again, of the structure that actually creates a beautiful space. The building above that is the Parliamentary building by Hopkins again. The image on the right shows how there is no need for suspended ceiling. All the mechanical, electrical is controlled. The facade is designed as a usable artifact. The daylight is controlled, the artificial light is controlled, and at the time this building was produced, it was one of the most least energy-intensive buildings in the UK. Manchester Art Gallery, again, the structure, this was a project by my good friend Jonathan, who's no longer with us. Bill, who actually led the project with Jonathan at the time. It's a beautiful display of structure. Again, trying to do the integration of services. If you look at the ceilings, the way the mechanical engineering has been engineered into the precast structure there. Welcome Trust, I was going to mention this, but I was going to go on to talk about these buildings that Hopkins did in Brunei, as we're beginning to play with the self-shading elements of the local climate. And we were also having a lot of fun with Bureau Happels in Dubai, doing this fantastic exhibition center, again designed by my good friend Jonathan. And again, the project didn't go ahead. One of the first towers that Hopkins did, this was realized pretty much as you see, without the spire on the top, but it got built. Those strategies of creating public realm where city blocks are brought together to create a public realm at the ground level is another one of the Hopkins project. The top left shows the blocks are produced. The top middle shows you the public realm that people can move about through the natural shading of the buildings above them. And the atrium spaces allow daylight to occur. And again, it's a beautiful manifestation of utilizing the strategies of comfort, sustainability, and what the locality has to offer. The old Dubai, the old India, or old parts of Delhi, old parts of Lahore, are all these places of my own experience that can be brought to expression here. And then very quickly, we're just going to move on to this project here. Is one of the last projects we did as RMGM with Calatrava. And again, this structure, the facade, all had to be retested, and it was a fantastic collaboration with these wonderful engineers we worked with. And another one of my favorite projects with our friends from France, Bureau Happels did all the engineering, some beautiful, fantastic engineering on the inside, beautiful craftsmanship over the internal spaces, and the scale of this is absolutely fantastic. On to some of the work of my current company. This is some of the projects in Kuwait. Another beautiful project of SSH in Kuwait, and some of the work that we've been doing in Oman itself. This is a wonderful project that has a beautiful shading to mask the sort of control of the project, and again, a shape that responds to the climate. And I think there we are. Thank you. Keep safe. Mariam, how am I doing?
Fantastically. Thank you again. And apologies for interrupting you. It seems that a lot of people have a lot of interesting questions. And I wanted to make sure that all of them are answered, especially for the participants, because I'm sure a lot of the answers will be very, very incisive and interesting. So I'll kickstart the Q&A. We have one of our first questions. Would the climate crisis have increased the collaboration between architects and engineers?
Yes.
How so?
I'm just going back to the Pompidou Center. There's something that happened. The Apollo program was just one of those magical moments where it brought the entire globe together. The television, the idea that man was going somewhere, and the filtration of the technologies that NASA produced to the world of architecture allowed every facet of the contributors building environment to start becoming proud of what they were doing. Pompidou Center was the first project where every collaborator of the building trade was able to say, look, we did this together, without which we can't move forward. How we solve the global issues is implicit in how Pompidou came together. And I think that's how we're working as we go forward. So that's the spirit we need. And we've got plenty of specialists around the world. We just need to bring them together in a way they don't have to worry about the salaries. Otherwise, they keep looking at the clock. So, my time is over. I can't give you my services. And being able to get together.
Our next question is, I guess this person perhaps knows you. Arif, the first project you showed was the Taj Mahal, a World Heritage Site. Heritage buildings generally lend themselves to light, and interest is often in the shadow and what you don't light. With a few exceptions, I do not see the same level of sophistication in the lighting of modern structures, which are often glass, steel, and concrete boxes. I believe this leads us to what is becoming an essential and exciting collaboration between architects and lighting designers. What are your thoughts?
It's a very good question. It's an amazing question. But let me go back to why the Taj Mahal. Taj Mahal is in my bones. It's in my character. It's in my geography. It's my genealogy as an Asian. But to see this artifact still surviving 350 years, it tells me there was something permanent about it. Very fundamentally, it's actually about a woman. It's about love. It is the only building that represents love. And it's the only building that's liked by every person around the world. And it is about the man and the woman. It's about man's love for the woman. Is very important, without which you cannot conceive. So I think starting from that point onwards, the robustness of its engineering is absolutely incredible. It's unique. So that's second thing. That's why it's there. It's just surviving the test of time. The next thing is the play of the shape and the form. You have to go to the force of the molds to see how they actually created those environments that worked without the air conditioning. That's another lecture for another day.
And your thoughts on the collaboration between architects and lighting designers? So that was I guess the third part of the question. What are your thoughts on that?
Very fundamental. If you don't know it yourself, you have to ask. If you want to ask the biggest question of life, go to a priest, imam, or a rabbi. What the world is all about. You have to ask the question. You have to be a believer. If you don't know how to do lighting, ask. Find somebody who does. Barry Hannaford was a great collaborator. I brought him into a project about 6 years. I found him, I looked for him, found him, dragged him into my own project because I wanted to be able to talk to somebody who wasn't looking at his watch and say, look, my time's running out, Arif, I can't charge you for this.
I like the whole answer of when you go to those religious figures, what is the fundamental aspect that they will mention?
This is absolutely fundamental. In this pandemic, you cannot go around the world without asking those questions. And
correct.
We're all in it together. There's a guy on the Twitter keeps saying to everybody, guys, with none of us getting out alive from here. So
He's being honest.
Absolutely.
Okay, so our next question about the role of collaboration between architecture and engineering in creating the optimal and best architectural decisions for sustainability, and to basically allow the building to serve the truest interests and needs of the majority of people. It's quite a loaded question, but I think the fundamental, I mean, the just to boil it down, but how is it that you can take this collaboration between architecture and engineering and fulfill the requirement for sustainability and meeting the needs of its occupants?
Okay, fantastic question. Again, it puts to shame our professions to some extent, because our professions are designed for exclusivity. You share your knowledge for a fee. But the reality is that if you're going to solve the world's problems, you need to become a dweller of the planet. You need to see what it is like to live in a tsunami. You need to see what it is like to live in a situation where you can live for $50 a day. And you need to be a person who can live in amongst every class of people, appreciate their problems, and solve their problems at their level. You cannot be sitting in an office in some high-rise building in the city of London and beg to know the solutions to somebody who's suffering in an earthquake in the poorest parts of the world. You cannot do that. So knowledge is very important. Humility is very, very, very important. You need to be extremely, have the most basic humility to be able to live the same as those people who are suffering from these massive issues we have. Otherwise, we can't solve the problems.
I agree. As one of the comments posted by the attendees is that you cannot always buy it in dollars. There has to be some kind of aspect of humanity in what you design and your thought process, which I strongly believe in. And I believe a lot of times it's lost during the design process, because it's all about taking advantage of every square foot or every square meter that you have of that particular land. Another one example or another question that was posted. I am interested to see more human-centric and well-being design consideration trending, as well as biophilic design considerations, especially in Europe. Even 10 years ago, office buildings were all about maximum massing, maximum office floor space, and now I see buildings with smaller office floors and large outdoor terrace garden spaces. How does this trend translate across the Middle East and Asia?
Yes, it's constantly changing. When I first came to Dubai, we worked for DIFC. They built the first building and the floor plates were quite large. They couldn't find a single tenant to move into those buildings. So Gateway that we did had the option of giving a room that you can rent out. And it became very, very popular. In fact, they made their return within a year of that building being completed. The issue is not so much the building being small, large, etc. These trends happen because somebody else controls the money supply. When you control the money supply, the market reacts. The responsibility actually is with those people who can make the global changes, to be able to decide, listen, let's not allow such drastic things to happen here. Let's experiment somewhere else and bring these things in a very phased manner. Dubai is going through this very pandemic situation, and so is London. We're going to have to see what happens over the next 5 years to see how City of London survives, how parts of Dubai survive, how working from home is going to become much more prevalent. But the reality is this: the answer is that it's a shifting sand. The things will shift on a regular basis. The real answer is that don't become too arrogant. Keep the humility at the right level, so you can ask the question where they need to be asked. At the point where the people are suffering, how do you provide for them, as well as for those who want to, send rockets to the moon, to the Mars, which must do both. We've got to do both. But you cannot allow the world to be so disenfranchised and so polarized that one is looking at the other. You need to get that merger to happen, and humility is very, very important, where we can get that. Even the poor person can say, look, I want to watch this rocket go to the Mars. I want to be part of that dream with you. But I want to be the engineer who helps to do that as well. And a very classic example of that is that when the vehicle that went on to the moon was being designed, the wheels were designed by a carpenter who had no formal education. But the people who decided how that buggy was going to be designed realized that this answer doesn't really necessarily come from people with PhDs. You really need to have a cross-section of society. So they actually did a workshop where they had every kind of skill set that humanity had. And the answer came from a carpenter. And that's what the world is all about. Wisdom doesn't need PhDs or degrees or college degrees. It comes from all sorts of people. So let's have a world which is not disenfranchised.
Well, that was a very lovely answer. I enjoyed it greatly, actually. I didn't know that the buggy wheels were actually designed by a carpenter.
It's extraordinary.
It's interesting. Yeah.
The theory of knowledge, how it transcends. My own mother tongue is unwritten.
Mm-hmm.
For the entire generation before my grandfather, we never shared a book.
Wow.
I was the first my father was the first generation who could read and write. And I was the second generation who actually read a book from end to end and still have difficulty reading. That's why I'm an architect. So there are whole generations of people who communicated through sign language, through words. You know, the entire wisdom of society is passed through. And, you know, for someone like me to be given a thesis to write 50,000 words and then say, look, unless you write that, I will not give you a degree certificate, it's wrong.
Mm-hmm. Correct.
We need to have people for what they're capable of. Mm-hmm. And, you know, and that's a bridge, you know, we need to build or the time to come, inshallah.
Inshallah. So I have 3 more questions, and once we're done with them, we can wrap it up. So the next question is, how much has the conceptual imagination of starchitects, Zaha and Calatrava, tested engineers and driven energy technology? I mean, from my own knowledge, I know Calatrava is not actually an architect. He's a structural engineer, but he had merged the two worlds very gracefully. So this conceptual imagination, do you believe it had tested engineers and driven engineering technology?
That's a very good question. I really believe that all the people that I mentioned in my talk earlier, including Calatrava and Zaha, they are an incident in the history of this world. They brought a degree of contribution, and people after us will continue to do the same thing. And the world generates its own problems. It creates successful stories amongst us to solve the problems we have. We need the Apollo programs, we need the Zaha buildings, we need Norman Foster Hopkins and all these great architects' buildings in order to raise the level so that the rest of the architecture can be done so beautifully too. So the two extremes are necessary to raise the bar of the quality of the thinking process and to filter that through to raise the average level of the entire globe. So yes, they are important. What Zaha has done for the Middle East, the schools of architecture in this part of the world, is just ignited the interest in all the students that, you know, for the past 14 years, we've been getting students from some of the best schools of architecture here. When I moved here in 2005, I used to work with the American University of Sharjah very closely. And some of the best students who joined us are doing some fantastic work in this region. And in fact, the byproduct of the American University of Architecture has produced some local architects who are doing fantastic work. And I think the globalization has to recede a little bit. Partly in this pandemic world, we need to do that anyway. Let's stop the amount of travel we used to have and communicate the way we're doing right now, but allow the local intrinsic, and like yourself, Mariam, you need to rise up as you are doing, and some of the fantastic architects have been produced by local universities. The future is bright. It's fantastic. Just solve all the problems. Thanks. And hopefully pay for my pension too.
We got you. This generation will resolve as many problems as we can. Okay. One question that is perhaps more targeted at your personal experience. What was the most difficult project in terms of design and engineering that you had worked on?
Nothing. They're all dawdle. They're all simple as anything. Once you got great people, you can knock on the door. You can go to your father if you've got a problem. You go to your mother. I still do. I don't know anybody. I don't have a problem that I cannot solve. If I can't solve the problem, I pray.
Yeah.
I pray a lot.
I mean, that's a great way of looking at it. You don't look at it at a problem. You look at it as a challenge.
No, absolutely. There's nothing that can't be solved. The only thing that can't be solved is difficult human beings. I think if we collaborate, be less toxic to each other, we can be a very happy place. There's absolutely nothing we can't solve. What we can't solve, you pray.
Right. Well, in that case, what would you define as the most challenging? So the one that you feel like, you didn't have any issues, but you felt like it needed that extra prayer, that extra push.
The most challenging thing for me is the fear that we cannot push education to every corner of the planet Earth. That is if we stop doing that, we'll collapse on our own back. Mm-hmm. So the only fear is that when our education institutions can't push the agenda of pushing the education across the planet, if we fail in that respect, we will fail as human beings anyway. The rest of the stuff, what Calatrava does, is a dawdle, and these little towers, we put it together, matchsticks, we put it together. There are no issues. Those can be done overnight. And some of these engineers, honestly, they're years ahead of these things anyway. Yeah. No issues. Those we can solve is the collaboration, the ability to deal with human beings themselves is the biggest challenge we have. And alhamdulillah, we're doing it.
Great.
Just thinking good word.
Okay. So it's one of the questions here. So I'm just going to take these final 3 questions and then I'll close down the webinar. All the industries have evolved dramatically over the years. On the other hand, building industries over the past 8,000 years still within the same boundaries. On the contrary, we still admire historical buildings that we cannot imitate. Do you agree with this or not? And what do you think about the statement?
I think that our expectations are too high for the building industry. We don't need to do any more than what it does already, for God's sake. It's shelter, that's all it is, somewhere to cook and eat. No more than that. Some daylight, you're done. Where do you want to go? And one day we'll take a plane and go to Mars. To be honest with you, I'm just as happy working with a building that Abdul Wahid al-Wakil was doing with me in Brunei, made out of brickwork, which he learned from Hassan Fatih. Mm-hmm. And I was doing one of the world's most technologically advanced buildings at the time, and Abdul Wahid says to me, "Look, Arif, you're wasting your time." Oh, and I was. Really, as architects, we don't need very much, for goodness sake. Some basic shelter to control the rain and the wind, the temperature, the water, and a lovely kitchen and a wife. For goodness sake, what else do you want, Mariam?
We want to what we don't have. That's the reality, Arif. That's always going to be the case as human beings.
Dream on.
Okay. So this is more of a statement, actually. So I'll keep it towards the end. Thank you for the great presentation. Most of the projects shown in your presentation are public icon building, which are not limited by budget. How do you consider the efficiency, economical, practical factor, and last, feasibility of these buildings in the Middle East's current market?
I think the market will decide for itself, but as an architect, I'm not a millionaire. I barely made a living when I was in England, even as a director of Hopkins. But my grandparents lived in a house which had no air conditioning. And to be honest with you, I can live there again. There's no issues. We can get adjusted to anything. What we need is love and education, much more than anything else.
Mm-hmm. And that brings me to the closing statement, which one of the attendees had made, is the projects that I have admired best summed up with the statement that the purpose of the material is for the expression of love. So that was a very nice statement. And also we have another one. The limiter to creativity is not the budget. The limiter to the creativity are the ideas. So there you go, Arif. You have huge cheerleaders upon the attendees.
But there is no shortage of ideas either. I mean, the gleaming I see in my own children and all the fantastic young colleagues that I have. We had a situation back in Hopkins, an open plan office. The youngest used to sit with the eldest, and so they can put up with the snoring and snore to the old people, but also learn from the wisdom. And that continuity is what's this all the life is all about. We can live in mud huts, to be honest with you. There's no issues.
Right. So I'd like to end our talk today. Thank you, Arif, again for the immense amount of knowledge that you had given us, and the importance of a collaborative process when it comes to design, and how we can create this great synthesis between architecture and all of the complementary disciplines. So I just wanted to end it by thanking you again for taking time, and thanking all the attendees who made it all the way to the Q&A. I highly, highly appreciate the time you took to answer the questions and wait for them to be answered. So to all our attendees, for the upcoming week, we will be posting, as you can see in the screen, on the YouTube page, the video that you are seeing right now, and follow us. We have talks almost every week, whether it be by AIA Middle East or AIA International Region. You can follow us on Instagram. As you can see, we post all of our talks, the times, and the dates. And of course, if you're interested in becoming an AIA member, do not hesitate to visit our website and learn more about who we are, all the upcoming events, and maybe just signing up for our email updates. If you're not interested in becoming a member, you can get updates on all of our talks. Again, thank you all for joining us. We look forward to seeing you again in our upcoming talks. Arif, always a pleasure. Hopefully we can get you for more talks. So wait for those emails from me for any additional talks. And with that, we'll end our webinar. Do you have any closing statements, Arif?
Mariam, thank you so much. Grateful to all of you and the AI for this, the voice, if you like. Thank you so much.
Thank you. Have a great one, everyone, and good night.